We present our paper, RISeg, Robot Interactive Object Segmentation via Body Frame Invariant Features, which was done in collaboration with the Department of Computer Science from Rice University and University of Texas at Dallas. Segmentation of unseen objects is essential to a robot's ability to perform autonomous tasks. However, current segmentation frameworks segment static images and see failure cases, such as under-segmentation. In this work, we propose an interactive perception framework for segmenting unseen objects in cluttered environments. Our framework aims to gather the most sensory data from interactions with as little amount of scene disturbance as possible, as seen in the figure. RISeg proposes two major contributions in action selection and a designed feature for segmentation mask correction. Using an uncertainty heat map generated by a static segmentation model, we can heuristically generate a robot push with a goal of creating motion such that two objects do not move in the same direction. By separating the heat map into pixels we are certain to belong to an object and the pixels we are uncertain of belong to an object, we can do clustering on certain and uncertain pixels. Bringing them together, we draw line segments between certain cluster centers that are close to one another. The pair of certain cluster centers forming a line segment closest to a cluster center of uncertainty is chosen to gain information on. By selecting a random point in the cluster whose direction to one of the certain cluster centers is perpendicular to the drawn line segment, we can generate a push point and direction. Our designed body frame invariant feature, BFIF, is built upon the insight that two body frames attached to the same rigid body individually experiencing different rotations and translations in space will have the same spatial twist observed by any fixed world frame. This physically intrinsic characteristic of rigid body motions allows for the distinction of rigid bodies within a scene. Pictured is two body frames attached to an oval object. Once the oval object moves to the dashed configuration, the two body frames experience some motions that are not equal to one another. If we imagine the oval object to be infinitely large, our fixed space frame now experiences one motion while the two body frames still individually experience different motions. The same can be imagined for a rectangular object with two body frames. While the motions of the two body frames are different, the motion experienced at the fixed space frame is the same for both body frames. Now that we have covered both action selection and our designed feature for segmentation mask correction, let's take a look at a few examples of RISeg.